Today we're joined by Jeff Garzik, Bitcoin core developer and the founder and CEO of Dunvegan Space Systems, which is working on the BitSat project, deploying Bitcoin full nodes into orbit via satellite. Thanks for joining us, Jeff.
Thanks for having me on DECENTRALIZE.
Yeah, we're very excited to have you. So why don't you give us a little bit of your background prior to getting involved with Bitcoin and BitPay and all of these fantastic projects. Where did you come from? I believe you came from Red Hat. Tell us a little bit about your experience there.
Yeah, hailing from North Carolina and open source is really my background. I've been in open source for more than 2 decades, and starting out at Georgia Tech and just being able to dabble with any sort of software package that you could download off the internet. That was really just the most amazing experience. Jumping on the internet in the late 1980s, that was before the web, actually. I had the experience of being able to access this entire global village. That was way before Tim Berners-Lee invented HTTP, etc. But the beginnings were there. It was really an introduction to a global network and teaching me at an early age how to be a global network citizen. And from there, the next introduction was open source. Anyone who was on the internet in those days, or its predecessor network, Usenet, which is interestingly quite a bit similar to how Bitcoin sends its transactions around the world. Internet and Usenet had a culture of sharing source code. And that culture of sharing source code really had existed from the very earliest days of the internet through 1992, which is sort of when my experience with it starts. And from there, sharing source code really snowballed into what became the open source movement. And just as I was working as a programmer and system administrator at a local Atlanta dental area, it was a very interesting experience to submit source code changes, source code patches to Linus Torvalds, and actually have them accept them. I was amazed to be able to change this Linux operating system that someone had posted to the internet way over in the University of Helsinki in Finland, and to actually have my changes accepted really stoked the developer enthusiasm in me, and I kept submitting changes. And of course, the way open source works, at least in those days, they would give you feedback. They would say, no, that is completely unacceptable, and here's why. And that's key to the open source process as well, is feedback. And so you'd receive feedback from Linus and these other very smart developers, and that really became an excellent tutelage or mentoring into open source. So I spent the next 10 years doing that, as throwing spaghetti at a wall, as we called it, submitting source code changes to Linus, seeing what source code changes would be accepted, which would not, and really working with the community to find out how they want their software developed. That's what I love about open source, is just a rapid interaction with the community members, a rapid back and forth. And the open source community is a very vital and vocal community, and they'll let you know if you're going astray. So that's it's sort of a open source trial by fire. And that was an excellent introduction into the Bitcoin open source community, which is very vocal and energetic and young and disruptive as well.
So Jeff, can you tell us about how you first heard about Bitcoin and how you went from just hearing about it to being so deeply involved in the project?
Well, it was quite similar to my Linux background, interestingly enough. I first heard about Bitcoin in July of 2010, and the great slashdotting of Bitcoin, and that was the first wide coverage of Bitcoin that Slashdot, a news for nerds site that's widely read, published a story on Bitcoin. That was where Jed McCaleb of Mt. Gox and Ripple fame first heard about Bitcoin. That's where I first heard about Bitcoin. Many of our longtime community members found out about Bitcoin through that. And from there, it was, just like Linux, an open source project. Bitcoin absolutely requires that all source code be public and open to inspection. Otherwise, you can't trust it with money. And so it was a natural fit, just like Linux, to any open source developer. I downloaded the source code, which is just, as a programmer, it's just amazing to be able to peek under the hood, to look at revolutionary software, understand how it works. There are no secrets in open source software, and that's really what attracted me to Bitcoin as well. So you can download open source software. If you're a programmer, you can study it, modify it, and here's the key is you submit changes back to the original developers. In my case, this was Satoshi himself. Satoshi Nakamoto was the original open source project leader for Bitcoin. And in those days, very similar to how Linux used to run Linux, is it was the throw spaghetti at a wall method of submitting changes. You'd submit a source code change. Satoshi may or may not respond to your source code changes. If he does, you may or may not get feedback. It may or may not appear. It was a very chaotic early type of process. Thankfully, Satoshi recognized this early on, and he brought in Gavin Andreessen, who was at that time in July of 2010 a regular source code contributor. And Gavin really understood the open source development process and was a great help in just interfacing with the community, and I think he was a little bit better of a project leader than Satoshi was himself. Satoshi was absolutely a great designer, but not necessarily the best coder or open source project leader. So getting involved in July of 2010 mainly involved, I saw some source code, I downloaded it. As many other programmers, I started playing with it, writing my own modifications, and in particular on the mining side, on the Bitcoin mining side, I started writing some small changes, and I wrote the first CPU miner for Bitcoin that was external to Bitcoin itself. And so that really opened up the race for CPU mining. Then, as we all know, it was followed by GPU mining, FPGA, etc. And that was the first external miner for Bitcoin. And that was the first change that Satoshi accepted into the Bitcoin software from me, was enabling that external mining. So in my own small way, I set off the ASIC mining race, if you want to project 3 or 4 years ahead.
And so with that said, I had a quick question on the history of Bitcoin regarding from 2010 until now. Since you've been, a part of the scene since then, how do you see the development coming along compared to what you saw with Linux when you were a contributor to Linux?
Well, Linux really had that's a good question, and I get that pretty frequently. Linux really had a much more mature developer ecosystem. When I was involved in it, I was sort of, to make an analogy, I was sort of like a team leader. The word we used was maintainer, and I would have 10 to 12 developers submitting changes to me, and I would review those, test those, and then send those in turn to Linus himself. And so it's sort of like an upward flowing pyramid of changes where you have literally hundreds, perhaps 1,000 developers all working on the same source code base, the Linux kernel. And with Bitcoin, we just don't have that number of developers yet. And that's one of the things that I would really like to improve upon and change about the Bitcoin community is growing new developers. It is absolutely critical that we teach new developers about the Bitcoin protocol, how Bitcoin works, how currencies secure funds, how they transfer value, how you can write hash protocols that introduce trustless features into money. All of those things are very new concepts to both economic specialists, computer science specialists. Pick your specialty. It's really a brand new economy, a brand new knowledge base for people to learn. And as a result, if you haven't been involved in Bitcoin for years and years and been soaking this up, then you just have a big knowledge gap, a big learning curve to mount. And any sort of educational acceleration that I can make happen, I'm definitely pursuing. And so education in 2015 for Bitcoin developers is definitely one of my priorities.
So you've been doing a lot of interesting work. I know BitPay employs you to basically help contribute to Bitcoin Core. There's been a couple of interesting projects come out of this, and one that comes to mind in particular is the Impulse Zero Confirmation Network. Would you mind describing that and describing the need for that, and what other types of things would you like to see in the future be added?
Well, ultimately, the motivation behind the Impulse protocol was that the holy grail for Bitcoin is really instant payments. Bitcoin, as the lowest layer is currently designed now, the blockchain, it is more, as I term it, a settlement system. When you send someone Bitcoins, it is not confirmed into the blockchain until a miner has validated that transaction, stored it in a block, and then from that, it is not yet secure until other miners have built upon that with other Bitcoin blocks. We call that being buried in the chain, or having a certain number of confirmations for your transaction. And so from there, that takes a lot of time, and obviously that doesn't necessarily fit the brick and mortar payment type model where you go into a Starbucks and you buy a coffee, or you're shopping online and you want instant feedback for your purchase. Excuse me. And so the holy grail of a Bitcoin payment is something that is secure and instant. And so right now we have one or the other, where if we have an instant payment, then it's an unconfirmed transaction and it's not really that secure. Or we have a secure payment and you've waited for confirmations, but it's not instant. How to bridge that gap? Well, there's an interesting technology called payment channels, which can be used to bridge that gap. The key, unfortunately, is that we need to upgrade the wallet software to support payment channels. So the current Bitcoin wallet ecosystem does not support that. That said, once upgraded, this payment channel technology can enable many, many new use cases for Bitcoin that are currently not widely deployed now, notably instant transactions. So instant transactions really uses this payment channel feature to do something interesting. The way payment channels work, to provide a little bit of background, is that you first embed some funds onto the blockchain while also creating an avenue for a refund. And once you've done that, you set up a multi-sig negotiation with another party who's going to help you facilitate your payment. This is getting a bit technical for some of the listeners, but ultimately you're creating a multi-sig agreement to pay, and once you create that agreement, you embed funds in the blockchain. Once you've embedded funds in the blockchain, you guarantee that you're not going to double spend those funds away, and you can then use those funds for instant payments to Starbucks, to Uber, to pick your use case. So payment channels really enable that specific use case, and Impulse is built upon payment channels itself. So have we achieved the holy grail of instant secure payments? Well, I'd say that gets us maybe 90–95% there. Really, we're going to have to build some future layers into the protocol to enable all of the use cases that we want, both instant payment and not. But Impulse is really a big step forward towards that holy grail of instant payments.
It's absolutely fascinating. What other projects do you see out there similar to Impulse that you see as being as building on your work with Bitcoin that you like, or proposals for the improvement of Bitcoin that you'd like to see implemented?
Well, I'm very excited about one improvement in particular. This requires an update to the network policy rules. That's called a soft fork, and this feature is called the technical name for it is op check lock time verify, which is a bunch of technical gobbledygook for being able to embed a transaction onto the Bitcoin blockchain, and here's the key: it is impossible to spend that transaction until a certain time in the future. Now, what this primitive, or what this feature does, is it enables all sorts of protocols where you can commit funds to a certain transaction, to a certain effort. You're essentially making a promise and backing it with very real money. And you're locking up that money on the Bitcoin blockchain such that you're provably not going to be spending that funds for any other purpose whatsoever. And you can use that primitive to build refund transactions in multi-party scenarios. You can use that feature for many use cases where you can add some safety to the negotiation. You provably establish that funds are available, and you do that with the sort of the gold standard of proof in our community, which is publish it to the Bitcoin blockchain. So that's really exciting, but it also takes a majority of miners to agree to upgrade to this this new feature because, as I said, it's a soft fork, which is an upgrade to the network policy rules.
That's excellent. That's really exciting to hear. I think that there will be a lot of benefits to the sort of more widespread adoption of Bitcoin if we start seeing those types of things deployed. So I want to kind of transition. So Dunvegan Space. I was first introduced to this through the BitSat project, and you've recently sort of refocused your efforts on this. Why don't you tell us a little bit about your impetus for getting this project off the ground? And where are you going with this, Jeff?
Well, thanks for asking. I'm very excited about this new project. The genesis was, again, in the Bitcoin community itself. Basically, my hosts are trying to distract me here. The genesis is really in the Bitcoin community, increasing Bitcoin's resilience. I was thinking about many of the ways that we can increase Bitcoin's resilience, and one of the ways is alternate Bitcoin blockchain distribution. So the any number of ways to the technical term for it is spread or decrease the attack surface on Bitcoin is something that we can use to improve Bitcoin security. And specifically, if we can store the blockchain on other mediums that, thinking terrestrially, for example, we could store the blockchain on Amazon S3, we could store it on BitTorrent, as we already do. And all of these other mechanisms provide a backup in case the primary Bitcoin network is being attacked, is being DDoSed, etc. You still have a source of blocks. Now, you take that idea and you follow it to its logical conclusion. What is the absolute best way to get Bitcoin blocks? And that's really get them from space. From the standpoint of blockchain distribution, if you have a satellite that has the entire blockchain up in space, you don't have to worry about your satellite getting DDoSed. You don't have to worry about your satellite getting physically attacked. Unless you're the U.S. or China, etc. But for all practical purposes, once the satellite is up there, it's up there. And that was really attractive for the blockchain, But as I developed the idea and developed a network of satellites that would broadcast a blockchain all over the globe, it was clear that this satellite was so much more than just for Bitcoin. It was really a worldwide communications platform, a worldwide data broadcast and data processing platform. And so that's really what made me take the plunge into starting my own company, is that it was such a powerful idea, giving not just the Bitcoin community access to space, but finding some way to give everyone on Earth access to space. And that's really the promise of sort of the cloud as we see it on Earth, cloud computing, cloud technology. And what can we do to extend that to space? Imagine if you could provide anyone on Earth, assuming that they're a developer, with an API that allows them literally direct access to a satellite, to store data on the satellite, to upload new applications. In this case, you can upload your own Bitcoin D, your own Bitcoin node, or if you have an encrypted message project, you can upload that. If you have a Bitcoin Oracle, which is a sort of a bot-type piece of software which processes Bitcoin value transfer requests and evaluates them autonomously, you can upload that to the satellite and execute it. So it was really a software as a service platform that was born out of this very interesting resilience project for Bitcoin. So you can imagine any number of applications on the satellite which involve looking at the blockchain, introspecting the blockchain, or just using the extra bandwidth and extra processing power on the satellite for data vault applications, for additional cryptocurrency processing. Yes, if you have an alternate chain or a side chain, we will support that as well. We're open to all customers, even Dogecoin customers. If they can afford to put it on satellite, we'd be happy to have them. But it was really resilience morphed into this very interesting data processing platform that we hope to make available to everyone in the entire world.
That's really interesting, Jeff. I think it's going to be really important to go ahead and do this. Talk to us a little bit about your long-term vision. Like, what does a world look like when we have this sort of purely decentralized network that's accessible via space, it's accessible to everyone, and how does the sort of open source philosophy apply to, what your vision of the future is?
Absolutely. It's just like Bitcoin, just like with Linux, it's key to have an open platform. And what that means specifically is that customers deserve to be able to look under the hood to know what they're getting. With how that translates to Dunvegan Space is that we're going to be publishing the BitSat design that aerospace engineers can actually look through, and they can see what parts are on our satellite, how it's designed, what is the power budget, which is the term for how much power our satellite uses, what is the mass budget, which is the term for how much each of the parts on the satellite weigh. And those sorts of things are very critical to spacecraft development. For example, the weight issue, every additional gram of weight translates to dollars at launch. And to throw some figures out at your listeners, our spacecraft, it's a 10 centimeter by 10 centimeter by 30 centimeter CubeSat. And so it's pretty small, but it takes, based on weight, if it's a 10 kilogram weight, $300,000 to get that up into low Earth orbit. So that's a lot of money to you and me, but in terms of overall space costs over the decades, that's the cheapest that launches have ever been. And so it really introduces new business models. It makes space more accessible to more people around the world. And I think that that cost shift, that cost decrease, has really opened up space to so many more people, so many more businesses. So the long-term vision is really provide a open platform where everyone is aware of our capabilities, our rough costs, our resilience factors, etc. And from there, they can really build their own platforms, their own space startups on top of our platform, just like people build websites on top of Rackspace or Amazon. You know, we'll really be sort of a Rackspace in space.
As a follow-up to that, I know that you are going to be involved with South by Southwest coming up. Can you talk a little bit about what your involvement is there before we leave?
Absolutely. It's we're really excited about South by Southwest. It's going to be a fantastic opportunity for Dunvegan Space. We're really having, I'd call it a coming out party for Dunvegan at South by. We have a panel where we're talking about big data in the cloud, and that really fits with our BitSat vision of a cheap, decentralized platform in space. Because, and this is another key, is we're really bringing decentralized principles from Bitcoin into space. We don't just have one satellite or two satellites. We're going to have a constellation of 24 satellites. And just like a Bitcoin node can fail and Bitcoin keeps going, we can have a satellite fail and the satellite constellation keeps going. That's key to the many cheap, decentralized type approach that many of these modern technologies, both in space and on the ground, are taking.
Well, thank you so much for joining us today, Jeff. I know our listeners can find you on Twitter at jgarzik. They can follow Dunvegan Space and all the exciting things you're doing there at dunveganspace.com and at Dunvegan Space. Also see a lot of your work at BitPay. But are there any other projects you have coming up, or websites or things you'd like to highlight so where people can find all the interesting things you're doing?
Well, I'd love for people to visit dunveganspace.com and see sort of our long-term vision for where we want to go in the next couple decades. The satellite constellation is really the first step into space, and long-term we look at a strategy of Bitcoin and financial technologies as really being the foundation for space exploration. You can introduce Bitcoin into the spaceflight ecosystem, and you suddenly have space vendors, notably our vendors, accepting Bitcoin for spacecraft. Or you see with BitPay, BitPay accepts Bitcoin on behalf of Virgin Galactic, who is one of their merchants for space flights. And so this is just another example of how Bitcoin and financial technology are making inroads into specific, very, very new industries and disrupting them as well. It's a very exciting time in space, and it's a very exciting time in Bitcoin.
This is amazing. I think I can speak on behalf of us and all of our listeners when we say we wish you the best of luck in taking Bitcoin literally to the moon, perhaps beyond it. So best of luck at South by Southwest, and thank you so much for joining us.
Thank you for having me. It's been great.